Okay, in a previous video we talked about significant digits. Significant digits are used whenever the operator in a computation that we have is multiplying or dividing. Whenever we multiply or divide, we have to take into consideration significant digits or significant figures. Both of the terms are used interchangeably. However, when we are doing calculations or computations where we have addition or subtraction as the operator, we worry about decimal places. So decimal places are much more simple than significant figures. Remember, we had 4 rules in a previous video about significant figures. But for decimal places, basically, it's simply you count the number of the numbers that are to the right of the decimal. So let's say if I had 12.3456. So my decimal is there. So if I were to count, I've got 1, 2, 3, 4. I've got 4 numbers to the right of the decimal. So this number has 4 decimal places, DP, 4 decimal places. Or to do another example, if I had 126, we'll just say 126. So in this number, how many decimal places? Well, we don't see a decimal in here, but we know it's understood to be after the 6, and there are no numbers after the 6. So 126 has 0 decimal places. Okay? And in the previous video when we talked about significant figures, the reason why we actually care about this is because remember, your final answer cannot be any more precise than your least precise measurement. Okay, so let's say, for example, if I had this problem where I said 3.2365, so 2.2365, and I'm going to multiply that by, we'll say, 22.3. So when I get my calculator, if I take 3.2365 times 22.3, that gives me an answer of 72.17395. So this is what shows up in my calculator. But I'm not going to report this entire thing because I've got to look at my 2 different measurements. How many? Well, first of all, my operator here is multiply. So we know in multiplication, I'm going to worry about significant figures. Well, how many significant figures are in this number? None of them are zeros. So we've got 1, 2, 3, 4, 5. So this has 5 significant digits. None of these are zeros. So 1, 2, 3. We have 3 significant digits. So between these 2 numbers, the 22.3 is the least precise. So this means that my final answer cannot have any more than 3 significant digits. So if I take a look at this number, and once again, all of these numbers are significant, or if we look at all these, none of these are zeros, so we would look at the significant digits in this number. We would say they're 1, 2, 3, 4, 5, 6, 7. This number has 7 significant digits, but I can't have any more than 3. Well, if I start numbering, that's the first one, that's the second, that's the third, and that's the fourth. So if I can't have any more than 3, I have to look at the third significant digit. So I've got to look at this 1. So when I look at this 1, I look immediately to the right. The 7 is big enough to make this 1 round up to a 2. So in doing so, I would round this number to 72.2. Now this number has 3 significant digits, which is exactly what we needed because of this number. So the final answer that I would report using significant digits is this, 72.2. Now let's say, for example, if I had, say, an addition one. So let's say if I had, we'll say 22.89, and I'm going to add that to, say, 3.784. Okay, so let's even do this without a calculator. So I'd have 4 here. 9 plus 8 is 17. I'd put the 7, carry the 1. So 8 plus 7 is 15, plus the additional 1 is 6. So I carry the 1, put my decimal place. 3 plus 2 is 5, plus 1 is 6, and then bring down my 2. So my final answer, even if I did this in the calculator, I would get 26.674. However, our operator is addition, so this means that decimal places is what we're looking at. So if we look at this particular number, we don't have to worry about anything to the left of the decimal. This one has 2 decimal places because I've got 1, 2, numbers to the right of the decimal. This one has 1, 2, 3. I've got 3 different places to the right. So my least precise measurement is this guy. So my final answer cannot have any more than 2 decimal places. So if I look at this number has 3 decimal places. But if I count, so this is the first place, that's the second place, and that's the third place. But I can't have any more than 2, so this is the number that I really need to look at. So if I look at the right, a 4 is not big enough to make a 7 round up to an 8. So this number is going to stay at a 7, and the final answer that I would report is 26.67. So this number has 2 decimal places, which is exactly what we needed because of the precision limitation of this particular number.